Hi everybody, this is Riccardo Zamana. Welcome to this new Netcore Conf edition. Today I would like to talk with you about an important argument that is a lot of things put it together because it deals with GraphQL, that is a technology, and IoT, that is a context about development. Okay. Um, so this is a sort of join between two important arguments in the ICT world that in some way they have more than something in common. But first of all, we have to thank you to all the sponsors that permits this kind of events. And so thanks to Microsoft, Playing Concepts, Evenaid, Dyna Hosting, Iberis, Inteliquia, Elisha, Incamena, Vern, Insight, Lahona, and Sessionize.com. So two main concepts in the beginning. GraphQL and backend as a service are two different concepts because GraphQL is a language, okay? And so it's a language to ask data or to send it to a database or something like that. On the other side, backend as a service is a cloud service model. Okay, so don't be confused and don't confuse a technology with a service model. Imagine that when you talk about GraphQL, you talk to developers and you talk about a technology, but when you talk about backend as a service, probably you will talk about a new way to make money that is associated to a particular cloud service model. And that cloud service model permits to outsource all the backend aspects of an app, and so permits to delegate to external people, so to external developers, totally the development of the backend. And so your role is only to uh, write the front end and maintain the front end. Why we talk about the GraphQL? Because in every data story, REST did not solve the problem, the software reuse problems. Imagine that you have a microservice with a REST API fair. And after two versions of this application, you have to join other data and so on. The amount of APIs that you have to merge in your backend in terms of HTTP client rise up, and it is very difficult to maintain the connections and to deal with several kind of authentication systems within a single app. So REST did not solve the reuse problem because every time probably you have or you probably should change the REST API morphology instead of integrate 2 or 3 or 4 APIs with different authentication methods. So probably in your future, you will not reuse as is a REST API app. The second problem when we talk about all the errors that caused the born of GraphQL are related to the bandwidth and the compute size. Why I said that? Imagine that you have two API calls. The first one is to have the list of a device family. So you ask for all the registry about a particular device model, and so the response is an array of JSONs that contains the device ID, the device name, and nothing else, because you ask those information to a registry, so probably to a SQL database. And in your code, probably you will do a for each in order to call another API for every single data in the initial array in order to retrieve the status of a machine, okay, passing the device ID and asking for the device status, the device operation mode or operational status, or the device alarms, current alarm list, and so on. This kind of round trip is a problem in terms of throughput, in terms of bandwidth. And we can solve it using GraphQL, but not using REST APIs cycles. Okay. The third, the OData tentative was not good because it implied a sort of not so small architecture in order to be implemented. So probably the principal need is to have something like OData, but as a viable solution in small contexts. And the fourth problem, that is the most important opportunity that is solved using GraphQL, is the problem relating to the data supply chain. So when you want to find only the information that you need, and so probably you would like to ask to a particular API to give you only 3 fields or only 4 fields, or 4 fields and the fifth field only if one of the first 4 fields has got some value. With GraphQL, it is possible to change the request response paradigm, and doing this kind of implementation, every front-end developer can ask only for the fields that are needed and nothing else, without having round trips. So if I have to create an API for each different data structure, probably I would like to have a way to create a dynamic schema. Another important things. Probably, if I have more than one database, I have to develop an API app, one for each database I have, in order to gather the data. Because if I use one only application to interact with many databases, probably I will have problems in terms of maintenance of the code. But my dream is to have a way in order to gather data from many databases with the freedom of using one or more APIs, okay, without struggling with API URL merging phase, okay. And the third one is related to mobile apps, because if you think that in every mobile app you have to call many APIs, okay, and so you will have many round trips, probably your desire is to have mobile apps that works faster, okay. So GraphQL allows developers to specify every time they call an API in some way, okay, which is the query to be performed in order to retrieve only the data that is needed. So why do we should use GraphQL? Well, for several reasons, okay, but in order to address some problem or some opportunity in some case that is not addressed by REST. So API versioning is one, overfetching or underfetching or slow performance. As we said, the GraphQL is not a database, is not a substitute of SQL, is not a server-side tool, is not React specific. Okay, GraphQL is a technology in order to retrieve data in a more intelligent way. Imagine that the GraphQL runtime, it is a sort of interpreter that receive requests that are different because the query of a particular the query is put into uh, the request query string, okay, and the response magically is a JSON that is the result of the interpretation of the query, in which I can say, I would like to have this, this, and this field, and this field for every field that I already have. So you model the response when you do the request. And the response is a JSON that is perfectly compatible with your request in terms of morphology. Last but not least, GraphQL runtime can map several data sources, not only databases, not only REST APIs that are proxied with the GraphQL, but GraphQL gives you the possibility to merge up all these kind of sources and gives you the possibility to call one point in order to retrieve the specific fields of the first, the second, or the third database. Probably the most important question is when we should use GraphQL, because probably every time you have got a project, you have to think about if GraphQL is necessary or not. Okay, in some project, probably GraphQL is a bad choice. Okay, in my personal opinion, GraphQL is very useful when you have to read principally data from many sources and you don't want to struggle with authentication and you want to map dynamically from the top to bottom side what you need every time in terms of fields and in terms of morphology. Okay, but respecting the slide, these are the 6 use cases where you feel benefit, okay, using GraphQL. So if you want to cache data, you can use GraphQL in order to load the data and to make probably more queries using the cached data without accessing to the database, okay, but without thinking to the right strategy to have a sort of cache or data loader because it is embedded into the GraphQL runtime. And probably another use case is when applications without GraphQL probably have an high data transfer. And the third is probably the most important fact in order to choose GraphQL. Imagine the old but gold service-oriented architecture. The problem was to normalize data in terms of retrieving when the data comes from many sources. It's the same old problem. Normalization of data sources access within a unique request. And GraphQL is an alternative to access to many databases using one endpoint. So the fourth is a consequence. So collect data from different stacks. For example, in IoT, you deal with time series databases when you have to store and manage time series data, but it's not the preferred database when you have to store morphological different information about status of hierarchies. And so you prefer a documental NoSQL database. Or in the IoT, in the same IoT solution, probably you have to deal with caches, so key value caches or key maps or key sets caches, so Redis and so on. Or probably you have to deal with the classical relational database. But it's not a choice. In every IoT solution, you have got all these kind of databases together. And in this way, probably you have to use a sort of normalizer on top in terms of API access, and so GraphQL. And another important thing is when you want to decrease the amount of data that is passed to mobile apps, because you can define refined queries. Okay, so GraphQL versus REST. REST APIs are a sort of standard, okay, but it is a sort of architectural concept for network-based software. So when you have a network of endpoints and you want to address a request to a specific endpoint, and so you can use REST API. The advantage of REST API is that REST is a well-known and common language. GraphQL is different because GraphQL is a query language that puts on top of many kind of sources one unique HTTP endpoint, single endpoint. Okay, but behind the HTTP endpoint, you can have other APIs or data sources, so databases, for example. GraphQL is made in order to optimize requests. So you can do your own API with 50 fields. For example, a device registry can contains a full JSON in which you can have more than 50, 60, 70 fields. But, and so you have only one API that in the response of this API is all the fields within the device entity. But from the front-end developer, probably a developer in some page wants only the device ID and the device name. And in the page that is called the device detail, want all the devices, the device fields, or probably a subset, because all the data from the front end is tabbed, so is displayed in several tabs. And probably you have to call the API more times to refine only the fields that are shown in the specific tab. Okay, so performance flexibility. In terms of comparison, GraphQL offer many advantages, some disadvantages. The most error that every junior developer encounter is to consider that GraphQL can send HTTP status that are the normal HTTP status, such as 400, 500, and so on. This is wrong because the multiple status codes are a particular feature, an important feature that is defined in REST API, but not in GraphQL. So when you deal with GraphQL, think that even if you have an error, you will have a 200 status code, so a positive status code, but with an error message inside. Okay. Another important thing is that you have only posts using GraphQL, so you can't differentiate get, post, put, delete, and so on. So when you plan to do some CRUD application about an entity, okay, probably every time you do that, you assign the delete method to the delay, to the delete, and the put to the insert, the post to the update, and the get to the read, and so on. But it is not this way when you use GraphQL, because the method is inside the body of the request, and every request to GraphQL is a post request. So benefit and drawbacks of GraphQL. GraphQL reduce data transfer costs. So imagine that you have a data-intensive application that uses a lot of APIs, and even if you ask for the user thumb image, probably every time you call the device, the user registry, the output of the query shows more than 30 parameters, and you take only one. And this is a sort of transfer out that you will pay for nothing. Okay. And so when you reduce data transfer, probably you have a faster response, and probably a more faster response makes your mobile apps more efficient in terms of usability and so on. But what are the drawbacks? The drawbacks are related to the initial learning curve, because you have to understand when you have to use data loaders, when you have to use data stitching, many concepts that we can talk about them, okay, during the session. But the drawback is to learn how to write using GraphQL. This is my own opinion, okay. The principal drawback from the grammatical point of view is that the queries returns always HTTP to 200. When you deal with GraphQL, you deal with three main things. The capacity of mutate data. And so it is the corresponding of create, update, delete. Okay, so mutations are operations in terms of writing data. Queries, obviously, is the read operation, request the data. And there is another thing that is not so simple using HTTP, that is the subscription. Subscription is a sort of paradigm that is typical from a broker point of view. Imagine that you have the possibility to use a subscription, okay, in order to listen to some event and react when something happens, only using GraphQL. This is if you learn how to use a subscription, you can use a subscription in order to update pages when something changes. And for example, in IoT, okay, when you read the properties from a PLC, this is an example related to my work, you can read all the properties using two strategies, the polling strategies or the on-change strategy. So when the value change, you have a notification. You can put the data that is changed from the edge to the cloud. Okay. Probably the subscription method gives you the possibility to react in terms of front-end updates, for example, only when the data change. Query type. So when you want data, you have to put a sort of post HTTP, okay? But which is the content of this post? The content of this post is about what you want, okay? For example, in this case, I want the endpoint that is called all cars, and I want the only the attribute patent, okay? So GraphQL, imagine that GraphQL exposes only the endpoint, the initial endpoint, and is the client that says to the endpoint that is a not specific endpoint, is a generic endpoint, so slash GraphQL slash, and so it is the client that decide what data it really needs. In this case, I want all cars and I want the property patent, nothing else. When you have a mutation, sorry, the client choose which are the fields that have to be changed, okay? So for example, if I create a mutation, okay, create car, I want only to update two properties. I don't want to bore with all the other updates in terms of declaration passing the same value, okay? I pass only the differences. The subscription is a sort of connection. So when you call GraphQL with a subscription request, what happens? Happens that you create a connection, and the response is not synchronous, but you will have the response only when something changes. Okay, so you have to pay attention, because every time you call a subscription, you open a WebSocket, and so you have a connection that is maintained as active towards your GraphQL server. And so you have to pay attention in order to make a sort of disconnections in terms of timeout, okay? Probably this kind of call, so the subscription call, you can use it when you know that probably in some second or within a minute something will change, and so you will close the transaction, giving the result in the asynchronous way, and go back to the page, okay? Or probably you will update something in the page without refreshing all the page. Typical use cases. Imagine that you have some situation in which you can use GraphQL server, okay? But probably you have to understand which are the contexts, and probably you have every time to think about which is the right context to use GraphQL. For example, GraphQL connected to a database. Can you use it in this way? Yes, probably if you have only one database and all the requests are in terms of mutations, so sorry, creation, update, delete, I don't know if the GraphQL server is the good strategy or is a sort of proxy that proxies a normal API query. But if you have a GraphQL server connected to a database that is not well structured, so the table device is not subdivided into other tables, and so you have 80 columns table, and your users probably ask for 1 or 2 or 3 fields dynamically. Probably the GraphQL server is the best strategy in this case. Okay. And another strategy to use efficiently in GraphQL server is when you have many APIs, and so you want to map a sort of proxy between the user and many third-party APIs that you want to share with the user without giving him the direct connection. And so you put a sort of proxy, GraphQL, with all the efficiency-based systems that I already explained before. Okay? Or you can use GraphQL to do both. So when you have a unique application that needs data from a database or more than one database, and at the same time want to integrate data that comes from other services. For example, in automotive, when you have fleet management, probably you want to use GPS data of your vehicles associated with the traffic jam, associated with the weather, okay, that is preventively written in some database for determined hour. Okay, so at 5 o'clock will be sunny. Or you can use, for example, the same GPS position in order to retrieve information about usage of a machine. And so you want to pass the time series data of GPS, okay, or the instant velocities to AI-based API. And all this kind of different APIs or data sources can be called using one unique strategy. So in this case, it is very simple. And GraphQL, in some case, GraphQL can map directly the tables within a database. For example, if I take a commercial product that is offered in an open source version also, that is called Asura, okay? With Asura, you can map natively all the tables within a PostgreSQL or, if I'm not wrong, a SQL Server. So you don't need to develop nothing because you are connected the GraphQL server directly to a database. Every time you put a new table, that table is queryable from an HTTP endpoint. Legacy systems are well positioned even today. So we are full of legacy systems today. And so probably you have to normalize the strategy in order to access to many of those legacy systems. And GraphQL layer can act as a sort of integration layer between many kind and many ages of APIs. Or you can do both. Resolvers. Resolvers are a smart way to merge informations. Why? Why resolver? Tree. Okay, so you ask for some query, name, sorry. So you have an initial query, another query, another query. The resolver combine all the service, so ask for a particular name, ask for a particular user type, merge all together, and then responds to you with the exact morphology of the request. So, for example, the system architecture with a resolver is parse the schema, call the resolver. The resolver make its own work and give a result, nothing else. The data loader instead is a sort of resolver, okay, but can be better than a resolver. Why? Because you can cache the data that is loaded, and so within the window of the data loading cache, you can use directly this sort of abstraction in order to resolve other queries. You know, with GraphQL, you can use variables in order to, this is a sort of, these are some examples, okay? In order to use efficiently. So you can use, for example, a sort within, this is the query content. So this is the HTTP post content. And within this content, I can, this is the query, this is the variable, so in the content of, in the body, okay, this is in the query string, this is in the body, you can use the values in terms of filter that are used in the query to filter all the data. Another important thing is directives. With directive, you can skip or include fields. Okay. So, for example, I want this thing if who calls you include a particular field. So if include repos is set to false, probably in this query the repo is not included in the result because the directive include says that the condition must be true, and if you pass false, you can do the entire query. The aliases, this is very, very important, because if you know how to retrieve the data from the model, but you want to retrieve data in another with other labels, you can do redefining within the query which are the right labels that you want associated with the right result. Fragments, for example, are a sort of reuse of the code in terms of query logic. So, for example, if you define a fragment, after the fragment definition, you can use it in order to query and to send more efficient queries, because you think about not the attributes, but to objects that embed attributes. Regarding monitor, I have to go more rapidly. Which are the monitor pillars? First of all, the HTTP endpoint. So in your backend as a service strategy, the most important way to monitor your application is to monitor all the traffic that hits your API. In terms of concurrent calls or cached query instead of computed query, in order to reduce your data loader window times, okay? Probably you have to monitor all the query that users ask you in order to retrieve information about how many round trips are done by your server at the resolver level, or at the data loader level. And probably you have to trace how many times resolvers and data loaders are called in order to retrieve the amount of times that are not called, okay? Because the strategy is to have only data loaders and data and resolvers. Yes, obviously you have to tag every query with a tracing ID. So in your code, prior to pass the query content to the right executor, you have to trace it, and you have to trace which is the query, which are the parameters, which are the includes of skip directives, and so on. Because when you will analyze the defects in terms of chain of calls during your schema stitching, so the merging of several schemas, you have to understand what are the schemas that are that reacts in a bad way, or which are the schemas that are the best in terms of milliseconds. What is device modeling? Even if in this example I have reported IoT plug and play, that is a way, okay, to define how your device interacts with your application. Understand that you have to understand that device modeling is how you can describe your device from the application point of view. So from the center to the device layer. And every application probably wants a piece of the data that is stored or that is generated from a device. Okay. This is a sort of analogy between the device and the device modeling. On the other side, the user and GraphQL, because the user wants some attributes that comes from the APIs, and so ask for a dynamic schema, and so ask for GraphQL. On the other side, the device modeling is a sort of standardization in terms not of signals. Okay, you are not describing signals, or probably yes, you describe signals, but it is the way you do and the way you distribute this kind of information and new telemetry sensors and new properties and new commands in the same way is a sort of standard way. Okay, and from this point of view, some in this case Azure, it, at the 8th of October 2021, okay, and not implemented it's not the IoT plug and play doesn't have any relationship with the GraphQL, okay, because they want to separate the device world from the user experience world, even if in the architecture they said that the IoT plug and play probably will interact with IoT Central, that is a sort of central service. And upon IoT Central, you have to make your applications, so mobile applications. So probably in the future, someone will think about the possibility to distribute graph. This is my opinion. But think about in AWS, the thing graph talks about the two concepts as merged concept. So when you model a device, when you make a device model, you are implicitly declaring all the properties that are callable using GraphQL. And probably from this point of view, Microsoft is conservative. So want to share information only using REST APIs as a sort of standard. But from the IoT point of view, if you use REST API, probably you will do many round trips. Okay, in order to have only 2 attributes. And probably from this point of view, the best implementation is from AWS, in which you can find ThinkGraph, and within ThinkGraph you model the device, but all the properties, all the telemetry properties are queryable using GraphQL. Personally, I think this is the right way. But regarding Azure IoT plug and play, we can adjust what is the drawback of the usage of API standard HTTP APIs. So probably in order to have the the best architecture, probably you have to merge the API Central, in this case, APIs, and you have to proxy those APIs with the GraphQL in order to filter all the information to the user. Okay, think about that. You don't filter the call to the IoT Central. You filter only the traffic that comes from the GraphQL, so from the server, the final server, to the client. And this is, anyway, this is a good choice from my point of view, because you can minimize all the traffic. And so when you model a database, a device, you are thinking about all the possibilities in terms of data that a user can request to you. And so when you define your strategy in terms of IoT data, you have to find out a standard. And this is the digital twin definition language is a standard that is needed to model, okay, all the things, the fields, all the properties, all the commands that are within your device. It is very useful if you want to test even your GraphQL APIs, because you can use the mobile app that is a sort of device simulator. And with this device simulator, you can simulate a gyroscope, battery level, GPS positions, and so on. Okay, so many kind of telemetry or device properties. And you can turn your iPhone into an IoT device, and you can develop your own backend as a service using GraphQL, okay, that maps with several data loaders, or if you store the process data into a parallel time series database, but within the same GraphQL APIs, you can talk with the IoT Central APIs in order to retrieve device status and so on. So you can use, let me search the right slide. This, you can use extension, in this case from IoT Central. So for example, storage, okay. For example, Data Explorer, time series, for example, Synapse, for example, SQL. Not in this way. This is the way they promote, but using that way, okay, from device to GraphQL that map IoT Central and other data sources. This is the example. This is a real example. We talk about asset monitoring application. So we talk about several kind of data that comes from several edges, within a line. So it is a pool of machines that has in common one single process, production process. And within this architecture, we can use this case in order to confirm our thesis. So the usage of a GraphQL proxy that can be a proxy to other GraphQL server, or directly to other data sources, or to other REST APIs. In this case, I would like to show you, describe you all this schema. We have a machine that can send alarms, stoppages, operational status changes, and set of settings using auth path. So in this case, IoT hub that is acquired from a function that puts the data that is checked and enriched to an event grid that act as a sort of fan-out service. But this is only one pipeline, because another pipeline is when all the PLCs export periodically all the raw data to a particular edge folder that is stored into the plant, and this local storage, okay, is synchronized because it is within an IoT edge. So we installed the blob storage edge module, is synced to a normal storage on the cloud. And every time a new file is created, event grid rise up with the on file created event that takes the file and put it into ADX. ADX, time series database, is another way to another way to contains data. The third one is PostgreSQL, okay, and the PostgreSQL is filled by MES periodically, and so there is a sort of ETL from the plant to the cloud that periodically synchronize only the changes in terms of production scheduling. Okay, these are my data. Okay, probably something is missing in this schema, because all the hot data comes into another database within the PostgreSQL. So we have two databases, okay? But within the same object, we have two databases. So it is a PostgreSQL instance with two databases. One that is related to the IoT hub and auth path, and the second one is related to MES export jobs. Okay, imagine that all these kind of things must be at must be seen outside, and so in this way we created a unique AKS, so a Kubernetes, managed Kubernetes, within two things. Hasura, in order to map all the PostgreSQL tables, and our GraphQL schema application. It is a sort of solution, okay? Is a GraphQL solution made with Visual Studio that maps the ADX this way, the ADX, and so act as a sort of resolver between the request and the entities that are stored into ADX. On top of those graph schema services, there is another schema that is the GraphQL proxy. The GraphQL proxy is a sort of proxy. So unify all the requests, the redirecting to the right one, or can merge the result from one and the other into a single request. Then there is our reactive app that is made with Blazor, but it is not important in this case. Okay, this is how we solved the problem of heterogeneous data, that is sparse data between several data sources. Finally, I would like to thank the sponsors who made this event possible. And so, thanks for watching.